Hello, this is Andrea, and we are back again. This time we're going to be talking about Pythagorean Theorem. This is actually on your worksheet number 19 toward the back section. So let's just get into some of the questions here on your worksheet. Number 17 asks us, what is Pythagorean Theorem? Okay, well, that's kind of a big question. If we were talking about, basically the formula for Pythagorean theorem, you can say that that is a squared plus b squared equals c squared. Okay, we're going to get into more detail about what Pythagorean theorem is here in just a minute. When do we use Pythagorean theorem? Okay, so basically, when we are looking for the third side length of a right triangle is when we can use Pythagorean theorem. So let's just write that. So to find a third side length on a right triangle, and this is actually really important here, this idea a right triangle. It can only be a right triangle. We cannot use Pythagorean theorem for any other type of triangle. Okay, and I will go to a diagram here in just a minute so we can go into a lot more detail about this, but it's asking us what the hypotenuse is. The hypotenuse is actually the longest side of the triangle. Okay, longest side of the triangle. And we actually always call the hypotenuse C. Okay, and we'll talk a little bit more here about that in a minute. Given the formula a squared plus b squared equals c squared, they want us to solve for b. Okay, so we're really going to try to isolate b squared first and then solve for b. Okay, so we're just using our algebra skills to do that. All right, so if we knew that we were trying to isolate b, at least starting with b squared, we're going to want to subtract our a squared from both sides. Of course, a squared minus a squared leaves a 0. So we've got b squared equals c squared minus a squared. Now we know we can't combine those. They're not like terms, right? They don't have the same basis, same variables. Okay, so here's where we get into something that we haven't really talked about before. If we have a square and we want the square gone, we do the inverse, which is a square root. A square root undoes a square. Okay, it's kind of like how multiplication is the inverse of division, addition is the inverse of subtraction, a square root is the inverse of a square, and vice versa. Okay, but like the other properties of equality, if we square root one side, we have to square root the other side. Okay, well, that's okay, that's good. This is going to leave us the b, which we are trying to solve for. Remember, they're wanting us to solve for b here. So b is equal to the square root of c squared, which is the hypotenuse squared, minus one of the legs squared. Let's go to a diagram so we can kind of see what all that means. So let's just start here. This is actually in the back of your workbook. Mine says page 219, but that could change based on the different versions of the workbook. You would just look in your table of contents for this page. So it says here, the Pythagorean theorem describes the relationship between the lengths of the legs and the hypotenuse of a right triangle. So you guys can see here, we know it's a right triangle. It has the little right triangle symbol. And we always label the side lengths A, B, and C. Okay, A, B, and C. C, we know, is that longest side. It's the hypotenuse. It's also the side that is opposite the right angle. Okay, so that's another way for us to know where the hypotenuse is. Sometimes, it's a little bit hard to tell, especially if the right triangle is situated kind of at a different angle. And then A and B are what we would just call legs. A and B. And you know what? We can move A and B to either side. I could have called this side B and this side A. It doesn't matter. The legs can be labeled in either place, but the hypotenuse is definitely the longest side. We cannot label C in any other place. Now, one of the, I guess one of the shortcuts that we can use, I mean, we just did the same shortcut. We came up with this, whoopsie, we came up with this one here, right? When we took our a squared plus b squared and we were solving first for b squared by subtracting, right? We just did this. So b squared is equal to c squared minus a squared, and then we square rooted to both sides, and we came up with b is equal to the square root of c squared minus a squared. Now, why are we doing that? Some students like to go to these shortcuts. These are just kind of shortcuts. You notice here, C, if we were looking for the hypotenuse, we could just jump right to, okay, hypotenuse is going to be the square root of both of our legs squared, okay? Or if we were looking for one of the legs, then we would say either A or B is square root of the hypotenuse minus, right, the hypotenuse minus the other leg, right? So these are just shortcuts that some students like to use. I would say that's okay to do. It's not a big deal if you choose to do that. It definitely makes it a shorter process. But I also think that there's value in plugging it into this original formula here and just doing the algebra, right? Just going through the processes. All right, let's go back here and let's go ahead and try this out. Okay. Actually, maybe before I do that, sorry guys to go all over the place here, I'm going to go to this diagram of a calculator. This is also in the back of your workbook. Mine shows it's on page 191. Depending on the version of the, or which edition you guys have of the workbook, it may be shifted a bit, but you can look in your table of contents. So most of you are basically using the TI 30XS or a similar non-graphing calculator. You guys can, of course, use the TI 84 series, 83 series, any of the graphing calculators, which has similar buttons, but a lot more, a lot more options. But I kind of just wanted to go over briefly how you would use your calculator to find squares and square roots. If you're trying to square something, right? So let's go back here. If I knew that I was looking for a 4 squared, right, I would go to my 4, so that's what I would put in first, and then I can just go right to this square button. You can see I would click the x squared button, and what that's going to do is square the 4 for me. And then equals is down here, this enter button. Enter just means equals, and then it's going to spit out your answer. Okay, let's say we were going to the opposite of that though. Let's go the opposite way. So let's say that we wanted to square root our 4, right? We're looking for that. So what we're going to do is, you guys can see right here, we have a square root. I'm going to zoom in a little bit. There is a square root symbol right above this x squared. And in order to get to this square root button, which is actually colored, and it would be the color would be the same as this second button. Usually it's yellow. It could be yellow or it could be green. Usually those are the two colors. So how we get to that, the symbol above each one of the buttons on your calculator is first by clicking the second button. So that's what we would do first. We would click that second button, and then we would actually click the x squared button, and what that would do is bring us to this little square root button above it. Okay, and then we would put in our 4, and then we would click enter, and it should spit out then our 2. It'll square root that for us. So those are how you would kind of go back and forth between squaring something and a square root. I want to show you another option, an easy option for squaring something, or the beautiful thing about this particular button that I'm going to show you is it's for any exponent. This little button right here, it looks like a little hat. It's actually called a caret button. Not like the carrots we eat, but a little caret button. We call it a caret button. I think it's C-A-R-A-T, I believe. So we can take any number we want, right? Let's just keep with the 4 since we are doing that. We could take our 4, right? And then we would just click on our little hat, our little caret button. And then what that does is it says, it's an exponent button. So what this really says is to the ... It's waiting for us to say, what do you want me to raise this 4 to, right? So if we want to square it, we would put in a 2 right after that, right? If we wanted to cube it, of course, we would say 4 caret 3, and that would cube 4 for us, okay? So you can use that, and then of course we would click the enter button. You can use this little caret button for any exponent that you like. I like it because it's very simple. I mean, there's another way that you can get to buttons where it's automatically inserted into the calculator. You would go to a math button, which this particular calculator doesn't have, but you go to a math button, and then you could find like cubes and cube roots. This actually also has a cube root, but we're not talking about cube roots in this class. But here's a cube root button, or it's an X root, so you could take any root you wanted. So there's lots and lots of options on the calculator that you will eventually be able to use. But for now, what we're really doing is kind of keeping it with these basic buttons here to be able to manipulate the numbers and get to what we need. Okay. Let's go back to one of the problems here. I'm going to just take a look at 21. We're going to look at A. It says find the unknown length in each of the right triangles. Round your answer to the nearest tenth. I would always recommend you to be very careful to look at what they're asking you to round to. You will also make sure you include units. Okay, that's a real biggie. A lot of students lose points, for example, on the final exam because they forget to round or they forget to add their units. So what I would recommend, you guys, is to always label your triangle with the A, the B, and the C so that you're not confused as to what side you're solving for. Okay, so even though that's already labeled X, we can see that's a short side, this is a short side, and of course we can see that this is the long side. It's also across from our right angle symbol. So now that we're labeled, we know when we go to our original formula, let's just go ahead and write it. I'm going to go with the just the actual formula and just do the algebra of it. If you guys want to take a shortcut, you can, go to that cheat sheet or just kind of use this idea above, and solve for the side that you want to using your shortcut. Let's go ahead though and plug in the information that we have. So I don't know A, which eventually is going to be my X. I do know my B. My B is 12 inches. So I'm going to keep my A. And my B, not my B squared, just the B is 12. So I have to square that, right? This is just the B is 12 equals 13 squared. All right. And basically, from here, you guys have a couple choices. You can go ahead and figure these out here, or you could possibly just say minus 12 squared on both sides and keep it as the square and then do the math at the very end, right? That's okay. That's up to you. I'll go ahead and just figure these out since these are fairly simple. 12 squared is 12 times 12, which is, oopsie, not 114, 44. 13 squared, or 13 times 13, is 169. I know that I have to solve for A eventually, so I'm just kind of slowly isolating A. A squared is equal to 25. Okay, now we know that A is our X. We know we need to solve for A, not A squared, right? We notice we have this square here. So we also talked about the fact that the inverse of a square is a square root, right? So A is going to be the square root of 25, which is 5, okay? And I always would recommend that you guys look back at your work and ask yourself, does it really make sense? For example, if your solution was 15 here, right, instead of 5, we would know we did something wrong because one of our legs can't be longer than the hypotenuse. The other thing that you guys can do is just do a quick check. Do a quick check. We now know the side lengths, right? We know that we've got a 5 squared plus a 12 squared has to equal 13 squared. So 25 plus 144 better equal 169, otherwise we did it wrong. And indeed, it checks out. So we know we did that correctly. All right, now sometimes your triangle is shifted a wee bit. And what you might want to do in that case is just to draw it out again so that you kind of know, what you're looking at and what side you're actually talking about. Okay, so let's go and draw our right angle mark, and we can see here, over here, we've got this tall length here is 9, so I'm going to go ahead and just put that here, 9 inches. And you know what I realized I did here? I told you guys to use units and then I didn't. So A is equal to 5 inches. See? I make mistakes too all the dang time. All right, so 9 inches. Okay, my base I can see down here is 4, right? So now I know what I'm really solving for. If I called this my A, my B, I can see that I am solving for my C, right? In this particular case. Okay, so now I can just go ahead and write out my formula. And I'll just plug in what I know. Okay, I know my A is 4 inches, plus 9 inches squared is equal to C squared. 4 squared is 16, 9 squared is 81, 81 plus 16, 97 is equal to C squared. And I want to square root both sides, right? I want to square root both sides. And if I'm uncomfortable with that C being on the right, I can switch it around. It doesn't matter. So C is going to be the square root of 97. And if we go to our calculator and we take the square root of 97, let's do that. Take out my calculator here. All right, so we got the square root of 97. That actually originally gives me 9.8488, wow, 57, It's a long irrational number. So then I always have to go back and remember what it asked me to round to. And remember that this asked us to round to the 10th. Okay, so we know that we're rounding to this place value here. This next number is a 4, so we're going to keep the 10th as it is. And when we have a rounding like that, we do this little squiggly equal sign. This means an approximation. So C is approximately 9.8, and I look back at my my units, and it's inches, so I keep it at that. Okay, so I can plug this in to be my 9.8, and of course you guys can go back and check it just to make sure. One thing I wanted to bring up is that there are triangles that we call special triangles, special relationships. And interestingly enough, a 5, 12, 13 is a special relationship that is always true, a 5, 12, 13, or any multiples of that, like if we multiply by 2, right? Anything like that. This one will happen to be a special triangle as well. And I'm not going to give you that answer, but when you get that answer on B, you'll know that's always going to be true. That particular relationship, those first two are special triangles. You guys can look up other ones. And so the cool thing about that is if you know two sides you know, for example, that 12 or 5, 12, and 13, if you knew that the hypotenuse was 13 and one of the sides was 12, you would automatically know that the other leg was 5, and so forth. So it's kind of a cool thing to know. Okay, so you guys are also going to have these application problems to do that deal with Pythagorean theorem. And it is always helpful if you have a diagram. Of course, you can see in 22 through 24 you have a diagram. Sometimes you don't have a diagram, and it makes it a little bit harder. So like with any application problem, you want to make sure you read it very carefully and make sure that you draw a sketch for yourself that will help you to understand. So here we have, let's do this problem. A major league baseball diamond is a square shape. Okay, that's important. Square shape that measures 90 feet on each side. If the catcher throws a ball from home plate to second base, how far is he throwing the ball? And of course it gives us a hint to draw that diagram. Okay, well, baseball diamond, right? A diamond basically can be a square, right? It's in that shape. We just shift it sideways. So let's just do that. We're just going to draw a square here. And of course, if we have this as home plate, this will be our home plate here, then we can label our bases, right? This is going to be first base, second base, third base, right? And the pitcher always stands out here in the middle, right? The pitchers stand here. Now let's go back to the question. If the catcher throws a ball from home plate to second base, how far is he throwing? Okay. So what we're interested in, if the catcher is here and he throws to second base, we want to draw a line there. I'll get rid of the pitcher mound here. We don't really care about that right now. So we can see that this is the distance that we're trying to solve for. This is our x, so to speak. Okay, so what we can see then is we've created these two right triangles, because we know with a square, right? We know a square is defined as one of the defining identities of a square is it has 4 right angles. Right, so we could just basically use this as our right angle, and we can just kind of utilize this whole right triangle, excuse me, as our to help us with our problem. Boy, I can't talk right now. Okay, so we can also use this information here that we have 90 feet on each side. So we've got 90 feet here, 90, 90, and 90. Okay, this information is really helpful, right? Because it's going to help us to know what our A, B, and C is. So we could even come off to the side here and just kind of draw it again if we wanted to, and we could label it our A, B, and C, right? We know that our X is our C. Doesn't matter on these sides what our A and our B are, how we label them. But in the end, this is actually what we're looking for, okay, the hypotenuse. All right, so how about we just plug it in? We've got a squared plus b squared equals c squared. We know our a and our b, so we can plug those numbers in. We've got 90 squared plus 90 squared is equal to c squared. The cool thing about squaring is that you can, squaring, I should say, bigger numbers with zeros. You basically square the 9, okay, which is, of course, 81. And then when you square a 0, it doubles it. So that's going to be 8100 plus 8100 equals c squared. And you guys, of course, can use your calculators to figure that out, too. So if we add those two together, we've got 16,200 is equal to c squared. And you guys could have used x squared instead of your c. You know, it's completely up to you how you set that up. All right, so when I take the square root of 16,000 200, I get a fairly big number, 127.279. And, we're asked at the beginning to round to the nearest tenth. So we're rounding to the 2, the place value where the 2 is, and we can see the next number is a 7. So we're going to round up. So we're basically going to say C is approximately 127.3 feet. Okay, so that is our answer. And then, of course, you guys would want to check that. You can go through that process of checking just to make sure. I mean, a check is sometimes kind of a pain to go through the steps of it, but it really is comforting to know when we plug all the information into our check that it works. We know that we answered the problem correctly. Okay, guys, so that is it on Pythagorean theorem. And just make sure that you guys are practicing the problems, if you're rounding correctly, that you are including your units. And yeah, we'll talk to you soon.